Once we have defined the polar form of the complex numbers, then the product and the quotient of complex numbers becomes easier. In the previous video, we talked about the product of two complex numbers when we convert them into polar form. In this video, we will talk about the quotient of the two complex numbers after converting them into polar form. So we suppose that you have two complex numbers. They are in the Cartesian form, and if their polar form is given, suppose that their polar forms are radius 1, so z1 corresponds to radius 1 and theta 1, and similarly z2 corresponds to radius 2 and theta 2, such that the z2, the second complex number, is not equal to 0 because you are not allowed to divide by the complex by the 0 number with any complex number. So if you are given these two polar forms of complex numbers such that the second one is not equal to 0, then you can easily find the quotient, which is z1 over z2. So z1 is divided by z2 is obtained by dividing radius 1 by radius 2, and cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. This is the way how we divide. So this is we have to prove, okay? Since we are given two complex numbers, z1 and z2, so we have to prove when we divide them, we get this value, okay? So let's prove this first and then we will solve an example. So since you are given z1 is equal to r1 times cosine theta 1 plus I sine theta 1, and z2 is given also because it is equal to r2 times cosine theta 2 plus I sine theta 2. So we can write z1 divided by z2 equals, here you will put the value of z1, which is equal to this one. So I will plug this value, and in the denominator you have z2 because z2 is equal to this one. Therefore I have plugged this value. Since in these quotients you have two different things, r1 and r2, which are real numbers, which are radii, and this thing which is complex number, this is also a complex number because this also involves I, and the denominator cosine theta 2 plus I sine theta 2 also involves I. So that means these two factors are complex numbers because they involve I. R1 and I2 are real numbers because they don't involve I. So we will write R1 and R2. We will separate these two things and then I'll write these two things. So in order to solve this thing, in order to write it into a complex form, we have to multiply and divide by the conjugate of the denominator. Okay, so I will write here, since the conjugate of the denominator is cosine theta 2, and here I will write minus I sine theta 2. Okay, because if you have a plus bi, then its conjugate is a minus bi, right? This is the conjugate. So in order to take conjugate, you have to change this sign, okay? So that means the conjugate of this number is this one, okay? If you have the product, the quotient of two complex numbers, in order to write into a simplest form, you have to multiply and divide by the conjugate of the denominator. Since this is the denominator and this is the conjugate of the denominator, you have to multiply with this thing. Cosine theta 2 plus I sine theta 2, sorry, the conjugate is minus Okay, so I will write cosine theta 2 minus I sine theta 2. Now, I'll multiply the numerator with the numerator and denominator with the denominator, right? So I'll multiply this term with this term, which is cosine theta 1, cosine theta 2. Then I multiply this term with this one. So if you multiply cosine theta 1 with minus I sine theta 2, you will get minus I first and cosine theta 1 sine theta 2. Now you multiply plus I theta 1 with cosine theta 2, you will get plus I sine theta 1 cosine theta 2. Now you multiply this thing with this one. Plus I minus I is minus I square. You will write minus I square. And then sine theta 1 times sine theta 2. Okay. Similarly, you will multiply the denominator with the denominator. Multiply this with this one. You will get cosine theta 2 times cosine theta 2, right? Cosine theta 2, cosine theta 2. That means cosine square theta 2, because the same thing is 2 times, right? Now multiply this with this one. You will get minus I cosine theta 2 sine theta 2. Now multiply this with this one. You will get plus I sine theta 2 cosine theta 2. Now multiply this with this one. You will get minus I square sine theta 2 times sine theta 2. So both are the same terms, so I will write square, right? Now if we simplify these values, R1 over R2 is a real number, so nothing to do with this one. Here, if you check, I square is minus 1. Since I square is minus 1, so here you have minus I square. If you write minus here, then you will get plus. So minus I square is plus 1. So in place of this thing, you will write plus 1. Okay. So cosine theta 1, cosine theta 2. And then here you will write plus 1 times sine theta 1, sine theta 2. Plus 1 times, so no need to write 1. So sine theta 1, sine theta 2. Okay. So these two terms are done. Now you have to write these two terms. In these two terms, you have I common. Since I is common, so I can write I. First you will write this term because sine theta 1 cosine theta 2. Since I is common, so you will write this term without I and this term without I, but this negative also, because I took only I common, I did not take negative common. So first of all, I will write this term, okay, which is sine theta 1 cosine theta 2. Then I have to write this term, but with this negative also. So negative cosine theta 1 sine theta 2. Okay. Since this I is already outside, so no need to write I again. In the denominator, you have, again, minus I square is plus 1. Because I square is minus 1, so minus I square is plus 1. So I'll write cosine square theta 2. This is plus sine square theta 2. Cosine square theta 2 plus sine square theta 2. This is cancelled with this one because both are same terms but with opposite sign, right? Because this is also this is minus I, this is plus I, right? And sine theta 2, sine theta 2, cosine theta 2, cosine theta 2. So all of the terms are same, only the difference is minus and plus. Therefore, I cancelled these two things. Now, if you look, R1 by R2 are as it is. Now, if you look my previous videos, maybe on the trigonometric formulas on the complex numbers. So in those videos, I have proved that cosine of theta 1 minus theta 2 is equal to this thing, and sine of theta 1 minus theta 2 is equal to this thing, right? So these are the two different formulas for the difference. Because in that video, I proved this formula with in which here we had plus and here we had minus. So if you change this sign, then this sign will get changed from here. So that means this is the formula for the difference, and the formula for the addition is this one here, and for the difference is this one here, right? So we will use these formulas here. So that means this whole thing is equal to cosine of theta 1 minus theta 2. So in place of this value, I will write cosine of theta 1 minus theta 2 plus I as it is. And in place of this value, I will write sine of theta 1 minus theta 2, right? Sine of and also we know that cosine of the same angle and sine of the same angle, if they are squared, for the same angle, if they are squared and they are added, the sum of their square of the same angle, it is always 1. This is called Pythagorean identity. That means sine square theta plus cosine square theta is always 1. If this angle is same, right? You can check. This angle is same here. Both are squared. Therefore, this thing is equal to 1. This whole thing is 1. So I will write 1 here. So these are the important formulas which are used to prove this value. So the final result is R1 divided by R2 times cosine of theta 1 minus theta 2 plus I sine of theta 1 plus theta 2, right? Okay, these are the formulas which are used here. Interestingly, this is equal to Z1 by Z2. You know what was Z1 times Z2? Z1 times Z2 was the product of these two things, R1 times R2, and this same thing but with plus here, right? Sorry, here you have plus, minus. So cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So if you multiply two complex numbers, that means you are multiplying their radius vectors and you are adding their angles, right? But if you are going to divide two complex numbers, that means you are dividing their radius vectors and you are having the subtraction of both of the angles. This is the difference. So this is from the previous video. I have already proved this thing. And here, when you divide two complex numbers into polar form, then you get this formula. Now we do an example. In this example, you are given two complex numbers. R1 is 8, R2 is what? 2. Theta 1, this is theta 1 and this is theta 2. This is R2, R2 and this is R1. Okay, now you are asked to divide you are asked to find z1 divided by z2. How will you find it? Here is the solution. Since z1 by z2 equals, by the formula r1 minus r1 divided by r2, cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2, because of this formula which we have proved just couple of minutes ago. Okay, so this is the formula. You know what is r1, what is theta 1, what is r2, and what is theta 2. So plug these values here. Since r1 is 8 and r2 is 2, theta 1 is 30 degrees. So I will write 30 degrees minus theta 2 is 135 plus I sine of 30 degrees minus 135 degrees. If you divide these two things, you will get 4 cosine of minus 105 plus I sine of minus 105 degrees. Okay, this is the solution. Now, if you look at these complex numbers, the first one has radius 8 and angle 30 degrees. If I draw it onto the complex number, onto the complex plane, it will be 30 degree angle here and big length of 8. So here is the length of 8. And the second complex number has radius 2 and angle to the x-axis is 135. So the second complex number has the length 2, the small length, which is 2, but the angle is bigger, which is 135. Okay, so these are the two given complex numbers. In this way, you can always find a complex number, draw the complex number by just drawing the angle and its length. Okay, this length is 8, this length is 2. You can draw their length, you can draw their angles. Now I have to draw a new complex number which is obtained by dividing these two complex numbers, which is this one. So I need to draw an angle of minus 105 and a length of 4. Okay, since previously we had positive angles, so therefore I went in this direction. But now I have negative angle, so I will go from here to here in opposite direction. Okay, previously, so you are staying here. If you have positive angle, you have to go from here to here. But if you are here, you are given a negative angle, that means you have to go from here to here, downwards. Okay, so from here to here until this line, I have 90 degrees, negative 90 degrees from here to here backwards, but I need negative 105. So I have to go ahead of 90 degrees. So here you have minus 105, something like this. So we have drawn an angle of minus 105 and a vector whose radius is 4. So that means this length was 8, so half of the length of this one, which is 4 here. Okay, in other words, if you are given two vectors and this vector was up and this vector was down, because you had z1 by z2, what you have to do, you have to divide this whole length into how many parts? Into these many parts. There were 2 here, so you have to divide it into 2 parts. The one part will be the length of the vector which is given, which we had to find, right? And the angle will be the difference of these two angles. Okay, and the difference of these two angles was this one, but in the opposite direction. So this is minus 105, but in the opposite direction. So this is your result. These two vectors were given, and this is your result. So this is the way how you divide two complex numbers. Let's do some examples. I'll give you some questions. If you are willing to try those questions, you should try. But just the way I have done the question, first I have solved it mathematically and then draw its diagram. So here are the questions. You have to find z1 divided by z2. So z1 is cosine of minus 35 degrees plus I sine of minus 35 degrees. And z2 is 2 times cosine of minus 35 plus I sine of minus 35 degrees. Let's change the value here. Here you can have minus 55. So I do not want to make the same angle in both of the complex numbers. In the second part, you have to find again z1 by z2, but here you have z1 is equal to square root 5 times cosine of 36 degrees plus I sine of 36 degrees. And z2 is equal to 8 times square root 5 cosine of 104 degrees plus I sine of 104 degrees.